Okay, so we're just going to continue on with naming ionic compounds. So constructing the name of the ionic compound given the formula. So this is where the last video left off. So we're looking at multivalent metals. We have SnO2. So the first symbol here is Sn, and that's tin, and we recognize that that is multivalent. So tin can assume a charge of +4 or +2, but we don't know which one it is at this point. So we have to figure out what that's going to be. So the second symbol is O, and that's just oxygen, so we know it's going to be oxide. Okay, so we will change the ending to IDE once we combine everything together. So let's go ahead and figure out what the charge is going to be on tin. So we have Sn. We don't know what the charge is, but we know that we have one Sn. So if you look here, SnO2, you know that you've got one Sn atom that makes up this compound. And then O, you have two O or oxygen ions. So one Sn ion and then two oxygen ions. And you always know the charge for oxygen is -2. So we can write down -2, -2. And now what you have to do is you have to give a charge for Sn. So if you take a look here, oxygen has a charge of -2 and -2, so you have a total -4 charge with the negative ions. So then tin has to be +4. So when you add these together, you get a charge of 0. So that's how you can work backwards to figure out what the charge is going to be. So when you group this together, it's SnO2. So you know you've done it right. So now you can go ahead and write down tin, 4, oxide. Okay, let's look at the next one here. NbCl5. So Nb is niobium, and it has a charge, or it has charges of +5, +3. So once again, we don't know what the charge is, so we can write down the name. We know there's going to be Roman numerals involved. We just don't know which one it's going to be. And we know that Cl is a nonmetal, and we know that it's going to be chlorine, but we changed the ending to IDE. So we pretty much have the name, but we just need the charge. So let's go ahead and work backwards and figure out what that charge is going to be. So Nb, we know we have one Nb ion, and Cl, it says there are 5, so we know we've got 5 of them. So 1, 2, 3, 4, and 5. So I'm just stretching out the charges, and we know that these are all chloride ions here. Okay, so notice you have a -5 charge, so then niobium has to be +5. So that would be the formula there. So niobium 5 chloride would be the answer for that one. PaS2. So actually, no, I wanted to make that PD. Let's change that real quick. Okay, so PdS2. So PD represents palladium. And once again, this one has more than one charge. So palladium is a multivalent metal. So we'll just leave the brackets and try to fill that in later. S is a nonmetal, it's sulfur, and we can change the ending to IDE. And now we just have to figure out the charge, and we can write down the Roman numerals for that. So palladium is Pa, and PD, and we have one of those. And then we've got sulfur, and we have 2 sulfurs. Each has a charge of -2. So then you take a look at the total charge that you have with the nonmetal, so it's -4. So palladium has to be a +4 to balance out the charge. So it's palladium 4 sulfide. All right, the last bit of naming here for ionic compounds looks at polyatomic groups. So now we want to go backwards. So we want to take the polyatomic symbol and we want to come up with a name for it. So the first thing you want to do is write down the name of your metal. So here we have a multivalent metal, so we know that we're going to be using Roman numerals. So CO is copper, and we'll just leave a space for the Roman numerals. And then we have this complicated group right here. So you know that it's more than one atom. So that's when you know that you have a polyatomic, when you have more than one atom grouped together. So then you turn to the back of your periodic table and you try to look for that group. And in this case, this is called dichromate. So we're just going to write it down exactly as we find it, because the endings have already been changed for the polyatomic group. So you just take the name as you find it and you write it down. So all we need now is to figure out the charge for copper. So copper, we don't know the charge, or sorry, cobalt. Oh, hang on, I've got to change that. I made a mistake. That's cobalt. So for cobalt, what we want to do is figure out its charge. So we'll just write down CO, and then dichromate, we'll keep it in brackets, Cr2O7, and that has a charge of -2. So the charge for cobalt has to be +2. Okay, so it's cobalt 2 dichromate. Okay, let's take a look at this one here. So Fe2SO4 3, the first thing we want to do is write down the name of the metal. So in this case, it's iron. And once again, you recognize that iron has more than one charge. So we're going to need to figure out what that charge is. And then this complicated group here is a polyatomic, and it's going to be SO4 with a charge of -2, so it's sulfate. So we're almost there with the name, we just need the charge. So let's go ahead and figure out the charge. So iron, we have 2 iron ions there, and sulfate, we have 3 of them, but we know the charge for each sulfate is -2. So some of you guys don't need to do this probably because you already know how to put these formulas together. But the reason why I am expanding them out is so you can see where all the numbers come from. Okay, it's not a simple crisscross the charge thing, which is how some of you are taught to name compounds. You crisscross the charges, but I like to show you where the numbers are coming from what ion, what charge coming from. So here we have a -2, -4, and -6 total charge on this side. So that means we need to have a total +6 on this side. So we have to split up that +6 amongst the 2 iron atoms. So each iron atom is going to assume a +3. Okay, so then iron, it's going to be iron +3, or iron 3 sulfate. Okay, let's look at this one here. LiOH. First thing you want to do is highlight the metal. So we have lithium. Lithium only has one charge. It's monovalent, so we don't need to worry about Roman numerals. And OH, more than one atom grouped together. So we look at the back of our periodic table, find the polyatomic that matches OH, and that's going to be hydroxide. Okay, and I think I just want to look at a couple more here just to make sure that we have tried some of the multivalent atoms here. Let's look at that one. And we'll go with CR2. Now let's go with that one there, CR3, PO4, and then 2 of those. So the first thing you want to do is you want to highlight the Cr, and that is chromium. Chromium is a multivalent metal, so right away add in the brackets to leave space for the Roman numerals. And then PO4 is more than one atom joined together, so you know it's got to be a polyatomic. So that's going to be PO4 is phosphate. So we can write that down there. Now we just have to work backwards and figure out what is a charge for chromium in this compound. So we have 3 chromiums, CrCr, and we have 2 phosphates. Each phosphate has a charge of -3. So now let's take a look at the overall charge. Negative charge that we have is +6 or -6. So what we need on this side is a +6 split up amongst the 3 chromiums. So then that would be +2, +2, and +2. So each chromium assumes a +2 charge. So it's going to be chromium 2 phosphate.